Hey, g'day, it's President. Thanks for stopping by. Now, I'm starting on a new project today, and it's influenced by a series of videos that I watched by Joe Pieczynski. That's his sticker there, and I'm wearing his t-shirt. But Joe does some amazing work, and if you haven't seen his channel, check it out. There's a link up above there now. But recently he's done this whole series of videos about making model machine tools. So I think he did a lathe and a shaper and a milling machine, a drilling machine. And on these models it's often necessary to cut long, slender, single point threaded components on the lathe. Now, in order to do that, he developed a travelling steady that bolts to the carriage of the lathe, and this supports the workpiece and allows you to cut these very tiny threads. And I was watching the video, I was absolutely blown away by how crisp and clean these little threaded components are. Now, I have a Colchester student lathe, which is different to what Joe Pieczynski uses, and I've had to adapt his idea to fit my lathe, and it's going to involve some metal casting and metal machining. And I've got some parts on the bench over here now, so let's go and have a look. This is a stock Colchester student travelling steady or follow rest, and this came with my lathe, and I don't think I've ever used it, but it's quite a nicely made unit. It's cast iron, has steel arms with bronze tips on them, and if you extend those two support arms together until they're touching one another, you can just about fit 3.5mm diameter stock and have it fully supported by the two arms there. Now, I doubt I would try to go much smaller than that if I was single point threading on my lathe, although Joe Pieczynski is able to do that. And I guess, yeah, for what I do, this would be okay, but it has one issue, and that is that you can only support the work from the top. Now, in the videos that Joe Pieczynski did, he actually cut very small threads by running the lathe in reverse and having the tool bit inverted. Now, in that configuration, you need to have support underneath the work, not on top of it. So with that in mind, this thing has some limited use for really small threads. So let me show you what I have in mind for making an alternate version that allows you to support the work from either underneath or on top. So this is how the design process worked for this tool. So what I did was I measured my lathe, I worked out the center distance from the top of the saddle to the center line or the center axis of the lathe, and then I designed a casting that would support a piece of linen phenolic. This is what Joe Pieczynski used in his videos, and he made his entire unit out of linen phenolic resin, but I figured I could do it from a casting and just buy this stuff for the actual support arm. So this rectangular piece here on the paper model is that linen phenolic, and I've got pieces in 12mm thick, 16 and 20, and you can buy this in 100 by 100mm squares from AliExpress, and it's not particularly expensive. And there's enough stock there for me to be able to make multiple arms, and as they wear out, they're sort of like consumable units, so as you use them up, you just sort of make a new one or cut it shorter. Now, after I'd done the CAD model, I actually just cut out the paper, full-size drawing, tried it on the lathe just to ensure that everything sort of worked out where it should. Then I laser cut the same part, and I was able to get a more accurate representation of how that sits on the lathe, and I'll show you in a minute where it goes. And then from there I was able to do a full 3D model and then print this in PETG filament as a split pattern. So that comes apart like that. This is the part we're going to cast, and then later on underneath it'll have some features milled into that base there that engages in a T-slot on the lathe. We'll drill some holes, we're going to do some slotting, and then we can make up the complete unit, which is really just probably 3 or 4 parts. So on my Colchester Student Mark 1.5, it has this really handy T-slot that runs along the front of the saddle, and that allows you to mount accessories in that T-slot, and they're adjustable in the X direction. Now, on Joe Pieczynski's lathe he didn't have that, but he had a couple of threaded bolt holes in the front of the saddle, and he was able to bolt his follow rest to that. So let's have a look at the actual follow rest that came with the lathe. So I'm going to sit that in the T-slot, and there are a couple of issues. Now, the first one is that it clashes with the rear tool post on this lathe, and I use that a lot for parting off. I can move it out of the way or remove it altogether, and that allows me to fit the follow rest. The other issue here is that the point of support from the follow rest appears to be too far to the right of the tool tip. So I've got the lathe configured here as if I was cutting a normal imperial or metric thread, and the tip of the insert is here, but the point of support from the follow rest is around about 30 millimeters to the right. Now I've played around with this and I can't seem to get a configuration that puts the tool tip directly underneath the point of the follow rest. So maybe I'm doing something wrong, but because of the other issues I spoke about where you can't support the work from underneath, I think that the homemade version or the Joe Pye version is going to work better for those little tiny threads. So with the tool bit in this position here now, we can put this laser cut profile into the T-slot on the saddle, and you'll notice that the tool tip is now only very slightly offset from this projection here, which will be made of that linen phenolic material. And you can now run the tool bit right up to the very end of the stock, and that would be in a position where you would start cutting the thread. You'll notice that it's being supported directly or almost directly behind the tool point. And you can also run up very close to the chuck and still have the work supported. Now you'll notice that there are slots that allow you to move this piece of linen phenolic material vertically, and also there will be slots that allow you to move it laterally in the X direction. Now in practice, what you would do on the end of this projection here is you'd cut a notch. Now the notch can fit either over the top of the workpiece, or if you flip it, it can go underneath. So no matter how you decide to cut the thread, you can always make sure that you're supporting the workpiece correctly. So I'll go ahead now and we'll try to get this casting made. Mail time, and got some new stickers. Now these are from Ralfy, who lives in the UK, says the rural part of UK, and here's his card, so I'll let you read that. But Ralfy's into vintage motorcycles, also vintage machinery, got a really cool workshop, got a really cool beard to go with the whole biker image. But let's get his sticker up on the door and check out his channel. I'll put a link up above there now. Alrighty, there we go, circular. There you go, Ralfy Customs. Check him out. That's the second time that's happened. Don't know why. At the end of the day, it's not going to matter. All of that's going to get machined off anyway, so I'm just going to leave it. But it's broken out of the cope, and yeah, it's going to leave that same shape on the finished casting. But easy enough to remove. I'm not going to do it again. So you can sort of see there where that sand crumbled away, but like I said, it's not going to affect the finished outcome. It's just annoying, and yeah, bad technique. Okay, get this close up and we'll get this one poured. Well, there's our finished casting. I've removed all of the gates on the outside there and just cleaned that up with a grinder. Now there is a lot of shrinkage on this face here, but when I made the pattern I left about 2 to 3 millimeters of machining allowance on that face there, so I'm fairly confident we can clean that up and make it flat. Now there are no set dimensions with this either. If I have to take off 5 millimeters, I don't think it's going to make much difference. So what we need to do now is to machine the features in the base here so it can sit in the T-slot on the carriage, and machine the slot in the top here for the linen phenolic support arm or finger. And yeah, then we're getting close, so I'll probably give this a really good sandblast and then powder coat it. So yeah, let's do these features. Need to get a reference face on this casting here, and I figured the best place to start is this long flat surface here, and we'll try and get out the shrinkage in the casting. So I'm just going to rest this on some parallels, and it's a bit of an awkward thing to grip in the vise, so I'm using one of these little screw ball gadgets, and we're just going to get a single point of contact on the moving jaw of the vise, and then we're gripped up against this flat surface here at the back of the casting. now that I've got a flat face on one side of the casting, I can bolt this whole thing to an angle plate, and I've squared the angle plate across the table of the mill, and I just sort of worked out roughly where the key needs to be that engages in the T-slot. So what I'll do is machine this surface off flat because it's got some draft angle on it at the moment, and then I'll reference the first edge of the key from this surface of the casting. I'll leave that rough, doesn't need to be machined off, but that'll be my reference. And then I've got to set out the key, which is around about 11 millimeters wide. I'll zero Z on the DRO now so I can set the depth of the cuts on either side of the key. This carbide insert cutter is not coping very well with this casting. High-speed steel is better, it's sharper, and there are always inclusions and porosity. There's also grit in the surface, and it doesn't play well with carbide inserts. So I'll swap this out for high-speed steel. Well, I've totally scrapped the setup that I was using. It just wasn't working. I could feel the casting was flexing as it was cutting, and it was leaving a terrible surface finish in here. So I've got a taller angle plate. I've put some paper between the casting and the surface of the angle plate, and that helps to make it grip better, but also it deadens any sort of chatter and vibration as well. And I've swapped out to a 10mm carbide end mill, which I was using on the same sorts of castings yesterday, and it worked okay. So I'll need to cut a little bit deeper, a little bit further into that shoulder, but that's okay, the drawings allow for that. While it's in this orientation, I'll drill the 2 fixing holes through the centre of the key as well. Alright, hopefully better luck this time. That's way better. There's a little tiny gouge mark just there. It's left over from the previous cut, but I'll leave that. So I just need to take the top off this surface here now, and then I'll step over and do the other side of the key. But yeah, it's all in the setup, isn't it? Alright, I think I only caught the finish pass on that side there, but the surface finish on that side is excellent. So I can use the DRO now to find the centre of this projection here and drill 2 8mm holes. Now the Colchester originally used 3/8 diameter hardware to hold this down into the T-slot, but I live in the metric part of the world, so it's going to be 8mm, and I will make up a specific T-nut to go with this, so it doesn't really matter what the diameter of those holes will be. But that's 10.9 wide, an 8mm hole will fit within that boundary quite easily. I need to machine a pocket here now. It's 26mm wide, 12mm deep, centered on that point there. And I actually set that scribe line in the lathe. So I put the casting in the T-slot. I had a scriber in the chuck, and I ran the casting past the scriber to work out where that center is. The circle there represents the width of the slot that we need to machine. Now I've got a pallet sitting in the vise here, and I'm using these Mighty Bite clamps that I made a while ago. These are like Aldi versions of Mighty Bite clamps. And when I first made these, I thought, oh, maybe they're a bit of a gimmick, maybe I won't use them very often. But for this sort of operation, they're absolutely excellent, because you can lift the part off the surface of the pallet, and later on I'm going to machine some slots which go all the way through, and I don't want to machine into my pallet. And just having two clamps that actually push inwards and then two fixed stops means that you can grip this sort of odd shaped part really securely. I've swept this face here with an indicator so I know it's sort of parallel to my y-axis, and so I can go ahead now and cut that slot, which doesn't go all the way through, but the other two will. So yeah, these things are brilliant. Okay, that's close enough for what we're doing, so I'm going to set the DRO to 0 there in X, and then we can offset either side. I didn't go the full 12 millimeters deep there, I just stopped short. I think leaving a bit more meat in the back of this is going to be beneficial. So that's 10 mil, it was 12 on the drawing, but I think 10's fine. Okay, I'll go ahead and cut these slots there, 6 millimeters diameter, 9 little center to center, and 20 millimeters apart in Y. And we've got a dirty great thunderstorm outside, so I'm just going to work through it. And let's hope we don't lose any power. Okay, so slots turned out good. The rain's really coming down now, so I'm going to break for a while. It just gets too noisy in here with rain on the roof. It's going to cut some of this 16 millimeter phenolic at 22 millimeters wide, just using my wood bandsaw. Okay, quick update before I go and fit this to the lathe. Now, off camera, I sandblasted that casting and powder coated that in grey, and I've made this one piece steel T-nut that goes underneath there. So that saves you having to mess around with two separate T-nuts when you put it in the T-slot. And then to retain that linen phenolic part, I've made a clamp plate. This is just some 6mm thick mild steel. Two steel parts been parkerized. And that grey colour there matches up with the other steady that I've made for the Colchester. So this one here is a fixed steady. This is one of the very early casting projects that I did in the workshop here. And it's not the best casting in the world, but it works. Okay, so let's go and fit this to the lathe now. Alright, so that just slides into the T-slot there. You'll notice that I can slide it past my rear parting tool. The regular Colchester travel rest clashed with that, and it meant that I had to slide it sideways or remove it altogether, but this one's fine. Now I've got a piece of 1/8 mild steel in a collet chuck here, and I'm going to slide it up to the workpiece, and I'm going to put this phenolic piece sort of in the middle of its range, so sort of in the middle of the vertical range and in the middle on the X direction there. And then I'm going to scribe off the bottom of the workpiece. You don't have to be terribly precise when you're doing this. Then it's going to hold that there. It's butting up against the workpiece. I'm just going to go underneath that with a scriber. Just give me an approximate position for the notch. Okay, so we're going to mill a slot there now, or a step actually. You can see that scribe mark, so I'm just going to mill off what's above that scribe mark there now. Okay, I've machined that step there back 1/8 of an inch behind the space here, because that's the diameter of the stock that I have in the chuck. But you can cut that whatever shape or whatever dimensions you want to suit the stock that you're cutting. Alright, so to assemble our follow rest, it just slides into the T-slot there, and then we can bring that up close to our stock. Alright, let's have a look at the job that I want to do here. Okay, so I've got a piece of hex brass stock in a collet chuck here, and I've turned down a cylindrical section to 3.18mm or 1/8 of an inch, and I've got to get the follow rest hard up against that stock. So I lock the follow rest down, and then we can do the rest of the adjustment with this finger here, and we've got to get the tool bit in the correct position as well. So I'll get all that done, and then we'll have a go at cutting the thread. So I've got my tool bit roughly where I want the threads to start. So I'm going to be threading in reverse. This is an inverted 60-degree screw cutting tool. So I'm going to start at what would normally be the thread run out position and then run the thread off the end of the stock. So with my piece of phenolic, and just for the record, I found out that this stuff isn't linen phenolic. I kept calling it that, but it's not. It's just a phenolic resin block. I should have been able to see sort of parallel lines or like grain lines in that material, which is the linen that's been impregnated with the phenolic, but it's not there. So this is not as wear resistant as a regular linen phenolic material, but for what I'm doing here I think it's going to be okay. I need to try to find some of the genuine stuff, the linen phenolic, but for now this will do. Okay, that's locked off. We can bring our tool bit into position. So the first thing I'll do is sort of create an undercut, and then we'll just thread off to the end from there. The other thing I've done here is got a hard stop clamp down to the bed of the lathe so that I can return to that same position every time. So let's do our first undercut. Okay, so it does produce a really nice clean thread. And I know what you're saying, oh well, brass is easy, you're cheating. But this is only the second one of these that I've done, so I'm still learning. But I'll go and get a nut and I'll try it on there. Okay, that sort of wants to go on. I'll do another very shallow pass. Alright, that's probably too loose, but it's not bad. That last pass was only 0.02 of a millimeter depth of cut, and it went from being tight to loose. So yeah, I need some more practice, but yeah, it shows a lot of promise. I could probably deburr that and get it feeling a lot better. You can still feel the crests on the thread. Like I say, I need more practice, but I like where this is going. Now the other thing you need to see here is that the thread does actually wear a track into the surface underneath there, and the same at the back in here. And you need to sort of take that into account, I think. So after you've done a couple of passes, if you sort of want a sort of spiral track in there, you might need to adjust the position of that finger there to account for that. But if this were the proper linen phenolic, I think it would stand up to that wear and tear a lot better. Now off camera, I did this one here. This is 3mm metric in stainless steel, and metric threads on my lathe are a bit of a struggle because you have to engage the half nut and then leave it engaged and run the tool bit back under power feed and keep cutting backwards and forwards that way. Now this is not the prettiest thread in the world, but it worked, and I'll do another one on camera so you can tell that I wasn't cheating. But yeah, it's a bit manky looking, but given that this is a single point cut in a fairly tough material, it's not bad. Anyway, I'll do another one on camera. Fucking idiot. Ah, oh, sorry about that. I just disengaged the half nut lever. It's just force of habit. Alright, we'll try again. Luckily I didn't cut very deep. Alright, what I'm finding is that there's always a little burr at the end there, and it's just as the tip of the tool exits the stock, it tends to flick away, but that's going on there now. I'll just clean that up with some emery. Certainly not Joe Pye standard, but I think that's a pretty good result for what I would normally do with a die. Even a die tends to tear the material up a bit. And this is especially good if you need to do a thread and you don't have the matching die for it. So you can basically cut any thread on your lathe gearbox using this technique. So yeah, I reckon that's a win. But just looking at that now, it is a bit on the loose side, but it's a serviceable thread that would hold. Well, I hope you enjoyed that today. Now, even if you can't make use of that tool the way I designed it and the way I built it, I'm hoping it will give you some ideas on how you might adapt it for your own metal lathe. Now, in the next video that I present to you, it's going to be the beginning of a quite lengthy series. Now, I've been working in collaboration with a toolmaker in New Zealand, and between the two of us we've worked out a project for you to have a look at. Now, it's a machine accessory to go with your milling machine, and it's a really super cool design. Now, even if you can't use it and it doesn't suit the mill that you got, there's going to be lots of interesting things to look at along the way. So I'm going to do a lot of metal machining, a lot of marking out, setting out. There's going to be some metal finishing and metal casting. So yeah, lots to see and do. So I'm going to leave you now with some wildlife footage as I normally do, and I'm going to see you next time for the beginning of this new series. So it's Prezzo signing out for now. Cheers.